Hey guys, Justin here from First Updates Now. I'm checking in from the Peachtree District Championship. I've got 1771 North Gwinnett Robotics, the third-ranked autonomous EPA in the world. They're going to talk to us today a little bit about that autonomous program and a little bit about their whole pivoting shooter system. All that on Behind the Bumpers.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the Join button in any YouTube video to pledge your support.
All right, so we got Joseph and Naga here going to talk to us about that robot. So it's made out of wood.
Yes.
Well, most of it's made out of wood. Before you guys go into the rest of the stuff, can you tell me a little bit about why you guys build your robot out of wood?
Well, the idea behind designing with wood is the fact that it's very easy to design around, and the engineering that can go into making wooden robots is sort of something that you don't have to think too much about, like the structural integrity of it. Whereas with aluminum, you have to think about the bending and the way that it sort of like is a little less durable in wood in some regards, whereas wood, even if it does break, you can just slap another piece of wood on it, screw them together, and then you have a brand new piece of wood.
Awesome. So it's kind of like
very
flexible, stands up impacts?
It's something that we can very much design around. You want to talk about that as well?
Yeah, I think also just like, for example, with prototyping, a lot of teams use wood just because of that rapid iteration. You can design a new part, get it cut out on a router, and it's ready in a couple minutes. And the same thing goes into our entire robot. We really can just design however we want, and it can come out on a router. And it just makes for a lot less machining time and lets us build more unique designs.
Interesting. Awesome. So let's get down to what everybody wants to hear about. Let's talk about that autonomous. Go ahead and walk me through that.
All right. So our autonomous always every year focuses, number one, on consistency. So start off with that, we do really heavy tuning. We're running the MK4i sort of modules like a lot of teams. And so we just spend a long time making sure we're able to get them to follow a speed and a rotation very well. Once we're happy with that, we go in a step-by-step process. Once we're happy with individual modules, we look at the robot as a whole. And we draw out a path using Pathfinder, Corio, or some kind of software that can create speeds. And you just follow that path without any kind of odometry correction or vision at all. Just follow the path and adjust your tuning until you're happy with it, how it's following. Then you can add in odometry, play around with that, get it to correct, and then you add in vision. So this sort of step-by-step process really helps us get that accuracy and that consistency down. And then moving into how we're able to make a lot of these paths, we're able to sort of break it down into pieces like a lot of teams have done, and use a procedural method to build these autonomous routines. So this is kind of a fun number to throw out there, but we can actually create upwards of 74,000 combinations of which nodes, which positions we go for in Auto, and that really just helps us work with our partners, against our enemies, and just really lets us do whatever we want to do in Auto and make sure that the programming is not a constraint.
Awesome. 74,000. Cool. So let's talk about that pivoting shooter and all that. What you got for that?
So the entire idea behind this pivoting shooter sort of starts with basically how our whole engineering design process starts at kickoff, with when we decide what sort of things we want on the robot and what sort of objectives we want to complete. So this year we realized, like, well, we can complete the shooting objective, we can complete the amping objective, and any sort of like fast movement and sort of working around our teammates who we're playing against. So that sort of led itself to an under the bumper intake, because that's something we realized, like, we're gonna have a lot of fast collisions, high speed collisions just like last year, and it's just been growing. So what we want is something that's very reliable and will always work, and something that we won't have to repair often. So that led us to the under the bumper intake and the raised bumpers in order to get the note to go underneath the bumper. So that was our first step. That was the first thing that we decided. Next thing was sort of this came in the next few weeks, was a pivoting mechanism for the shooter and the amp. So this was sort of a take on Rembrandt's chamfer, where they had sort of like a fixed shooter and amp design. This one is a pivot where it's able to come all the way to the up position for an amp or a trap, which I'll get into later. But this was first designed for the amp, and it can sort of come into this position where it's able to shoot into the speaker, and down in the down position as acting as part of the intake as well. So it's a very like reliable system because everything is in one position, centrally located, where it won't really be interacting with the other robots on the field or any other field elements. It's a very safe mechanism that is able to complete all the objectives that we first initially wanted to complete. Do you want to talk about how we went to the other parts like shooter and everything?
Sure. So one of the things we wanted to focus on was being able to control this smoothly, reliably, and without much effort. So we tried to focus all our gravity, our center of gravity, center of mass towards the actual pivot point up here. So even though it's at a high pivot and it's a really long, like over a foot long arm, you'll actually notice most of the motors are all located right next to the pivot, and we use long belt runs to power the intake portion. And then, yeah, from there we're able to, as Naga said, intake through this at the ground, and then it runs down a sort of conveyor belt system with polycord straight into the shooter, which we're running like a lot of other teams, the 3-inch stealth wheels from AnyMark. And when we were prototyping, we went through a lot of designs like a lot of teams, and we looked at different Open Alliance teams as well, looked at the side shooters, the top and bottom, and we noticed very quickly that spin was very important for ensuring consistency with shots. So we're running a Kraken on both sides to allow us to do a little bit of spin with the note. Anything you want to add on to that? All right.
And I see you guys have some of those carbon fiber boat hooks that Rembrandts were kind of looking at.
Yeah.
How'd you go through that process, picking that over something simpler?
So when we were just first designing the robot, we knew that trap was something we wanted to design for long term, but we didn't want to get caught up in focusing on that too much because it's honestly not the most important. It's helpful, but you don't want to get caught up and see your whole robot's built around something that's not that useful. So we noticed quickly early on that this amp mechanism could potentially turn into a trap if we could get off the ground. Unfortunately, all like the climber in a box options wouldn't let us bring our robot to the right height. And luckily this came out this year with some teams looking at in Chief Delphi, the chameleon climber. We're going to talk a little bit about how we got it working.
Yeah. So with the boat hook climber or the chameleon climber, we went through a lot of very iterative design processes where we first started off with just a simple motor and a spool, the motor powering a spool where it would spool up into a very short climber. We quickly realized that in our first competition at Gwinnett that it wasn't really a sturdy mechanism when just powered straight with that and doesn't have any assisting mechanisms. So we went through some different like designs of spools and also adding some assisting mechanisms like a constant force spring, which is something we had to work around a lot just to find the correct amount of force in order to just help it and not overpower the climber too much. If we can pull it to the side, I think we can get a better look at that.
Custom 3D printed mounting?
Yeah. So this is something that we worked on in between our 2 events. After week 3 at Gwinnett and week 5 at Albany. That was something that our main focus was sort of the climber and improving the intake. That was our focus for in between the competitions. And this is something that we were able to really get good at, trapping and climbing in a lot of our matches at Albany. And that's something that we sort of specialized in now because of the sort of iterative design process that we were able to go through.
3D printing, as you mentioned, it is a 3D print spool, and that really helped us with the iterative design. Right now, we actually do have some parts printing, some spare parts for our intake. And so we got the Bamboo Lab X1 Carbon this year. It's been a wonderful investment, and it's really helped us within a day. Honestly, sometimes we've been at the shop, noticed an error, redesigned it, printed it, and it was done by the end of that day, and we were able to test it and get data to go home with and think about over the next night. So that's really just helped us get really good at what's the problem, identify it, fix it, print a new one, and within an hour or 2, you can already be testing it again.
Awesome. That is a fantastic robot, guys. You've already won 2 qualifier events so far, so let's see how they do this weekend in the Peachtree District Championship. Thank you guys very much.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions.